Good afternoon, everyone. Thank you for the introduction. My name is Sotiris Ioannidis. I'm a research director at FORTH, the Foundation for Research and Technology in Greece. We're probably the largest research center in Greece. We're located, our main campus is in Iraklio in Crete. It's, I don't know, 25 degrees there. I'll be talking today about data sharing between industry and research. Just one correction. I'm a member of the ENISA PSG, not ENISA. So it's the advisory group for ENISA. Disclaimer. So thank you for inviting me. It's my first time in Belgrade and in Serbia. Unfortunately, I won't have time to go around. It's a very tight schedule, but it's nice to be here anyway. So let me just start by saying that we live in the big data era. Now, this is sort of preaching to the choir. And I'm going to spend the first few slides actually doing this. Just in the remote case, someone here does not believe that big data is cool. So apologies for the rest of you, the other 99%. And then in the second half of my presentation, I'll talk about a specific project that we're actually working on over the last couple of years. And so hopefully the intro is going to highlight some of the issues, and then I'm going to go a bit more into the details. Now, I probably have way more slides that I actually have time to go through, but I put them there anyway because I gave them to organizers and they can actually share it with you. So that's why they're there. If I don't make it, it doesn't really matter. I'll cover the important things. So we live in the big data era, and what does that really mean? Well, it basically means that data is everywhere, and when I say everywhere, I mean everywhere. So it's not like a company is building something and they have information about whatever they're building, or there's a website that just stores logs for their the people that visit it. It's pretty much everywhere. It's being generated all the time, and the speed of data generation is just absolutely mind-boggling. I'm not even going to give a number to it. But the numbers of sources have also increased. So it's not just websites, but it's also every device in this room is generating data right now. There's temperature sensors, there's like cameras, there's mics. So everything is generating data, and these data end up being stored in silos, and hopefully we can we can sort of do something about it. Now, I think the most interesting feature about data is not how fast they're being generated, but the diversity that I talked about. Because by getting the diversity and getting this information from different sources is how I think we can actually monetize things. We can make very, very interesting applications. So I think diversity is king, not necessarily size of data or production generation, but diversity. But again, that's my take. I dug up this slide from some time ago, so the numbers are fairly old. I have to get a student to update it for me. But even back then, like 10, 15 years ago, we're talking about billions of people generating data, or billions of devices, or tens of billions of RFID devices generating data. I think nowadays it's safe to just multiply by 2 or maybe multiply by 10. But even back then, it was just amazing how much data we're generating. So again, maybe for my next presentation, I'll update this slide. Okay, so now that I have you convinced, let me take a step back and talk a bit about the European data market. By the way, this concept I'm going to revisit later on in my presentation when I actually talk about the project we're working on, because it's closely related. But the idea behind the European data market is, the European Union realized that data is important. There's a big market there, and that the market economy is growing. It's a good way to generate new jobs. It's a good way to increase the competitiveness of Europe. It's a good way to drive innovation. Generally, it's a good way to improve our society. So Europe is investing very heavily on the data economy. Some markets from a study, the European data market, again, to give you some teasers. Back in 2016, so 5 years ago, we're talking about the data economy around 300 billion. Now it's like more than doubled. That's just money. If we look at the number of companies, we're talking about 250,000, 5 years ago. Now we're talking about almost 400K. If we're talking about actual people working on this market, we're talking about increase of almost doubling, like 6 mil to 10 mil. Now, there's a lot of information out there, a lot of numbers floating out there. So, you may have seen different numbers. I have actually found different numbers as well. Talking about so these numbers come from Statistica and IDC, talking about the data market growing from 50 billion to 100 billion, or the business analytics market growing from 100 billion to 200 billion. So you'll see a lot of numbers. I think the take-home point here is not if it's like 1 billion, like 10 billion or 11 billion. The take-home point is that it's an order of magnitude of hundreds of billions. I think that's the take-home point. Okay, so hopefully now you think that it's a good thing to invest in, and it's a good thing to do research in, to do your thesis in. But I think that the value actually comes from sharing. I said it before that the value comes from different kinds of sources of data that we can somehow combine. That's how we're going to get the best bang for our buck. So basically, how do we do this? The answer is with difficulty. I'm facing this as an academic every day. I don't have the data other than the data in my network, and I will go to my friends in industry and say, please give me your data so I can build interesting systems to process it, or interesting algorithms to process it, whatever. And I can give the standard arguments that okay, if I process your data, you get insights, and you can support your products, and build better products. You're gonna get value out of nothing. It's gonna be good for your company if you promote this. And I think companies get this. They totally get this, and they're actually doing their own processing, obviously. But there are a number of blocks to actually really opening it up and really opening up the community. And I'm going to mention a couple of important things in my opinion. First of all, companies think that this is obviously data is cash, so they don't want to open it up. They don't want to release it to the greater audience. But there's also a lot of things about privacy and confidentiality issues that need to be taken into account before you open things up. Hospitals, medical data, for example. I do research in that, by building systems that analyze this data. But if they give me the data, even if it's anonymized, it may get de-anonymized, and then what's going to happen is that lawsuits are going to follow. So companies are very, very careful on what they share and if they share it at all. So these are things that need to be really solved in order to really exploit the full potential of big data. Now, assuming that we've convinced everyone, what are the principles that would guide such sharing? So the principles that are floating around is FAIR. You may have heard of it. So it's an acronym, clearly. It's a really cool acronym. It stands for findable, accessible, interoperable, and reusable. And what does it really mean? Well, first of all, you need to be able to find the data, okay? If you cannot find the data, there's nothing you can do. So identify them with persistent identifiers. Provide as much metadata as you can to your data. Make sure you put them in repositories and you clearly index them so that people can go and find it. So that's a good way of making data findable. So companies should basically follow FAIR and start with making the data findable. Secondly, accessible. Make sure that people actually cannot just find it, but they can actually access them. So use standard protocols for interacting, for downloading, for getting. Make sure that even if you have to revoke some data, you leave enough metadata behind so that you can still do interesting things with it, even if the data is gone. So in the future, you may need to revoke something. Make it interoperable. So use as much standard formats as you can. So standards, standards is king again. Use standardized ways of processing, standardized vocabulary, because if you don't do that, you just won't be able to operate with it. And finally, reusable. I said before that data may disappear or may change a bit. So form them in such a way that you can still do processing in the future with old data and maybe come to the same conclusions or validate old results. So these are the guidelines that I think companies need to be following in order to really provide people with useful data. Now, in terms of building systems that can do that, yes, there is the issue of size and storage. Companies, again, know that. Industry knows that. You need to buy, tons of disk drives and tons of HPC equipment and stuff them somewhere in the basement. But that is not the main problem when doing analytics on data, I think. I think one of the main problems is actually, safety, security, privacy, control over the data. I think that these are the things that we need to be working on. Because let's say you still, let's say you want to open up your data and you want to invite people in and do experiments on your data set. How do you make sure that things don't break down? How do you make sure that things are not corrupted? How do you make sure that things are not corrupted? While at the same time, give them the full power to do the processing they want. So issues of security are probably even more important than where you do the storage or how fast you can actually run algorithms on the data. And the other important thing, in my opinion, is to make sure that you build an environment, that's safe, secure, whatever, but it also facilitates and helps people that are non-experts. You cannot always have the single expert that can do the perfect algorithm to find some insights on your data. We're not all experts on big data, and there are not enough big data experts to do the analytics we want. This ties in with a general shortage of skills that I believe we have, and actually Europe has identified that. And one of the keywords right now is skill building. Not just big data and big data analytics, but security, for example. I mean, actually, I'm a security person, so I know that there's shortage of skills in security. You're not going to be able to necessarily find the expert or hire the right people or hire the right consultants to do the analysis you want, but you still want to get some value out of the petabytes or zettabytes of data you have in the basement. So you want to be able to enable maybe middle management or some policy maker to do enough with the data to be able to make interesting decisions. So that's quite important. So this ties into the concept we have of big data as a self-service. So not as a service, but as a self-service. Meaning that you process it yourself. You make it easy. And I think that's one of the key challenges in opening up the data economy to the masses. Okay, so this sort of takes me to this work that we've been doing over the last couple of years, which is a project called IBDAS, Industrial Driven Big Data as a Self-Service Solution. So this is a good example of having a placeholder name and then not running out of time and not finding a cool name for your project. So we're stuck with this stupid name here, but anyway. So yeah, it happens. That's why you have to find the acronym before you start writing the proposal. So, for the rest of my talk, I will just give you an insight of what this work we've been doing is about. Very briefly, it's an EU-funded project. It has 13 partners. It's 5 million euros. We started a couple of years ago. We have about one plus years remaining in the project. And this is a research project. So the primary goal, I mean, again, I'm an academic, so my primary goal is to do cool stuff. But at the same time, make sure that this can somehow be transferred to industry so that industrial partners can get some benefit out of it. And it died. Or it didn't die. Okay, so our consortium, we have 13 partners, as I said, big industry, a bunch of SMEs, a bunch of research centers and universities. I just want to point out that the University of Novi Sad is actually a partner in the project. Do we have anyone from Novi Sad here? Cool. Our technical manager is from Novi Sad. He's a really cool guy. He does all the work. I get the credit. So it's cool. And it's a thank to him that I'm actually here. So, as I said, it's a consortium all over Europe. Also, IBM from Haifa is involved in the project. They do a really cool part of the whole infrastructure. Now, coming back to the motivation for this project, I said that I'm going to be talking about the data, the European data economy again. So this is something that started a few years back. There are documents dating back to 2014. There's a series of documents that are reports that want to promote the data economy in Europe. And Europe has formed this program of actually funding research that has to do with big data and the big data economy. So it's actually a quite successful program if you take my word. And it's because of this identification that if you invest in this, you're going to be improving society as a whole. You're going to be creating jobs. You're going to be driving innovation. So Europe is really pushing for this. They want to see value that we extract out of these big data pools. Actually, when I say Europe, I mean the Commission, the people that fund research in Europe, that fund me. There is a very strong push for openness. When you write the proposal, there's specific questions that they say, what sort of data sets are you going to bring in? I mean, yes, you bring these companies in the consortium and they get money out of us, but what do they offer back? What sort of data do they give back? What is their format? How open are they? Things like that. So there's a really big push for openness. And they make you write these open data management plans and how you're gonna, how all the procedures you're gonna follow in order to open the data. So it's quite a good initiative, I think, because I believe in openness. Now, the other aspect of the big data economy is the empowering the end users, and this ties in to what I said about the lack of skills and the push to get more skilled people into this. But still, we're always going to have a shortage. So whatever we build, we need to make it usable by non-experts as much as possible. I'm not talking about some totally random person that hasn't touched a computer before. That's not the kind of non-expert I'm talking about. I'm just talking about the non-data scientists. You don't need to have a PhD in data science in order to do some data processing. Okay, like you shouldn't be an expert or have a PhD in security in order to be able to use SSH. So that's not the type of person I'm talking about. The other identification within this big data market economy is the convergence of IoT and cloud. So this basically gives us the opportunity to generate data, store data, and process data. So there's this perfect storm in a good way. So this is like the background that sort of pushed us into this project. Now, what's our vision here? Again, this is a bird's eye view of what we're trying to accomplish. First of all, we want to have a complete and safe environment to do our testing. As I said, security is important, safety is important. The industry players need to feel safe that whatever you do with their data, assuming they invite you in, and they just don't throw you out the data, but they invite you in their organization to work on it, they want to have a safe environment. So, quite important. Secondly, self-service. So, one of the key driving forces of our vision is this lack of skills and enabling the non-expert to do cool stuff. Assuming we accomplish these things, we want, of course, have great impact. I mean, I write papers, so I'm interested in research work. Industry is interested in innovation, so I want them to get my papers and create new products. Increased quality in tools and analytics in general. So this would come out of the good research that we're doing. A way to quickly collect data, incorporate it, and process it. and be able to do that on heterogeneous platforms. So things that have all sorts of components, and they can also scale up or scale down in time depending on needs. So this was the vision. Now, we have sort of drilled down and sort of distilled it to two central points that I've been repeating over and over throughout my talk because I think they're important. The openness of data and the user friendliness. So even though there are 4 bullets, they're essentially two points here. And the concrete objectives we have is what we call, breaking the silos. So this was our motto, breaking the silos. What does that mean? Data lives in silos. These silos may be external, typically, but they're also internal. So it's not like, you have company A, company B, and they have their own silos, so, no one shares. But within company A and within company B, there are internal silos that are very, very hard to break. It's crazy. We have some really cool industrial, partners, and these guys would actually, try to get data for the project, and they knew that the data existed, and they couldn't get it. They couldn't get permission. So there's a lot of bureaucracy inside the organizations, a lot of legal hurdles you need to go through to even get access to your own data. So, CaixaBank, had to go get the records, couldn't get them, or Telefonica or Fiat. They were able to convince people, and little by little, they started breaking the internal silos. So it's important to break both external and internal silos. And this would, breaking the internal silos is important to get the value within the company, but the external silos would also drive the cross-sector data flow. So, information from, manufacturing, information from telecom. Maybe you can combine these two and build this cool new product. So that's one of the core objectives. The other is the user-friendliness, the self-serviceness. How do you build a platform that you can easily use? Lots of GUI stuff, lots of visualization, lots of drop-down menus, a lot of intelligence in the back end to guide the novice or the non-expert to run the right algorithms on their data set. I mentioned that we have 3 pilots. One is from Fiat, one is from CaixaBank, and one from Telefonica. Now, within those big pilots, within these domains, every company has a list of use cases that they want to experiment in. Maybe I have time to go over them a bit, but very, very, very quickly. So CaixaBank is basically interested in fraud. So they have a couple of use cases that have to do with that. So identifying online fraud or identifying fraud within financial terminals, but also some other project that wants to identify users by IP address, for example. Now, this was probably the most challenging bit of the work in terms of industrial pilots because they're highly regulated. So they had to jump through a lot of hoops in order to get this, to gain traction within CaixaBank and for the project. And they're actually able to provide synthetic data that we can use, but also actual data that they tokenize in a way, and you can actually play with the real data. The other use case that we have is the one from Telefonica. One part of it is they wanted to increase quality in data centers. So we got, and those were actually also hard records to get, but easier than the banking ones, or not as difficult. And they were about, figuring out what the quality is about, in call centers. Do you get satisfied customers or not? So we had audio records that they transcribed, and you can do a lot of analytics on that. And they had a couple of other pilots that had to do with mobility of users, and tied to that, how you deploy your antenna. And there we're talking about, a lot of data, really real-time data that flows to the network. I believe I have the number, like 4 terabytes of data daily that they get out of for mobility and that they need to process. And our last one, where I have a couple of slides, Fiat was interested in improving their manufacturing process for the engine blocks. So they have sensors on the machines that does the casting, so you get a bunch of data from that. But you also have an operator that can add things manually. So you get these hybrid solutions. And again, here we're talking again about terabytes of data, and the actual thing needs to run at real time. And we actually haven't got this one running at real time just yet, but the project's halfway, so we have some more time to actually do the optimizations. The other one has to do about logistics and maintenance. They have a fleet of vehicles and other components that they want to be doing preventive maintenance on, and they have sensors that get information. So these are actually real problems that these guys want to do. So even though initially we had a vague idea about, we want to do things in manufacturing or automotive or telecom, but they came to us and said, these are the real problems we're facing. I'm sure you guys in companies in this room probably have similar problems. We have a business school in the consortium that did some study about where this applies to. So it applies to a number of industries. It's not nearly as interesting. But in terms of structure, I mean, our project took the standard approach. We have a standard pipeline for doing analytics. So we have the user, the data, the analysis, and the results. So what we basically did was we went in each one of those and we injected the new stuff that we're building. So the way to do the self-service solution, the way to break silos, how do you create a safe environment. So it's a standard pipeline, only it's better, or at least we claim that it's better. I think I'm running low on time. Very, very, very briefly, again, you don't need to see the details, but there's a capturing component. This comes in from our pilots, but there's at the bottom there, maybe you see it, there's a data fabrication and storage, and that's actually quite cool. So IBM, one of the partners, has a tool for generating data, fabricating data, sorry. So you can come in within, you can specify what the data looks like, and then it runs, for hours and hours and hours, and generates 10K of data. So it was pretty abysmal when it started, but throughout this project, IBM was able to actually, increase the fabrication speed. This is actually an embarrassingly parallel task, so you can really parallelize and get very high speeds, but also interactively working with the pilot providers, they were able to refine their models on how to generate the data. So it's a very, very valuable tool because, as I said, you cannot always get the data that you want. In the middle, we worked on a number of things, new machine learning algorithms. I'm not an ML expert. I don't play one on TV. I don't care about that stuff. Some computational stuff and runtimes and languages. Again, I don't care about that stuff. But the thing that actually I like is the streaming analytics. And there we set out to increase the speed of data processing and to be able to do stream processing and real-time processing. And the way we do that is with GPUs. If I have a couple of minutes later, maybe I'll talk about that. And finally, we touched the entire let's say front end or back end, where you interact with the system. The architecture looks like that. The take-home point from this is that it's an end-to-end solution in the sense of, we start from the hardware, okay, and we go all the way up to the, to the user. So we touch every layer of the architecture. So we have a partner, Atos, that actually brings the physical infrastructure. We bring in GPUs, we put them on the machines, and we have the entire software layer. And we go all the way up to the top, where we have the user interface. Now, in terms of user interface, we formed it in a way to, as I said before, there's lots of drop-down menus so you can select your algorithms, but there's also a way to guide the user and sort of steer them the right way to use the algorithms that they need to be using. I'm going to be skipping everything else because there's no time. And I'm going to stop here and say, please follow us and retweet us and check out more information on our site. A lot of the info that I talked about, there's in a lot more detail in there. So do visit us. So thank you.
Just two questions. Why is it IBDAS as self-service and not simply IBDAS as a service? What is the difference?
Why is it as a service and not...
Why is it as a self-service rather than just a service?
Right. So the self part there is the keyword that we wanted to inject in the title to show that a non-expert can go in and do it themselves. So it's not. So it's like self-service at the
you don't need a
gas
clerk.
station.
You don't need a clerk.
Yeah, I don't need a clerk. I just go in there and I put gas in my own car, or I plug in my plug-in hybrid or whatever. I don't know. It's hype. I don't need someone to go in and plug it for me. I don't need the expert.
The other one is also interesting. The majority of academic system is still valued on papers rather than making data open, sharing data and code. Can you speak to the cultural shift that needs to occur in the overall research and academic world to prioritize data sharing?
Okay, so from the academic side, there's a lot of pushing by us academics against the publishing companies to make our papers more open. So that's about the publications themselves, not the data. So there's a lot of push. And actually, in the funding calls, there's a clause that says, the push for, gold access or green access, whatever it's called, to have everyone be able to access your research work. Now that's in terms of the research. Now in terms of the actual data, I don't have any. It's the okay. How many companies here? 3, 4?
More.
Come on.
10, 20.
If I come to you and say, give me your data, will you do it? It's their fault.
So that's, okay. Okay, so Sotiris, thank you.
Thank you.
This is a certificate.
Oh.
Thank you.